Hello dear students, welcome back. Today we are going to take up the second and the last part of chapter number 5, separation of substances. In the last video class, we had learned about different type of separation technique. Today we are going to learn some more separation technique. So let us start today's class by taking up some separation technique which we had not studied in the previous class. The first separation technique that we are going to study in today's class is evaporation process. Evaporation is a technique of or is the process of converting a liquid into the gaseous form. So when we take some amount of water and when we apply some amount of heat energy, then in that case the water molecules after absorbing the heat energy gets converted into the gaseous form from the liquid form. The process of evaporation takes place continuously in our surrounding even if we are not applying extra amount of heat energy. It is done when the liquid components absorbs the heat energy from the surrounding. So this evaporation process takes place even without the application of extra amount of heat energy. The process of evaporation is utilized in order to separate different components of the mixture. Say for example, preparation of salt from seawater. So in order to obtain the salt from seawater, the seawater is collected in a shallow pit. After that, it is allowed to influence with the sunlight. The heat of the sun vaporize or evaporate the water that is present in this area, leaving behind the solid particles of the salt. So in this way, evaporation technique is utilized to obtain or to separate different components of certain mixtures. Now let us come to the next separation technique. The next separation technique is known as condensation. The process of condensation is just the opposite to that of the evaporation. The condensation process is the one in which the gaseous form of a substance is converted into the liquid form. For example, the conversion of steam into water. So in this, the steam is in the gaseous form while the water is in the liquid form. The process of condensation takes place by reducing the temperature of the substance which is in the gaseous form. So this technique is also used to separate the different components of a mixture. So it is not that only one separation technique is used to separate out the different components of the mixture. In certain cases, two or more different separation techniques are used to separate the different components of a mixture. Let us say for example, the separation of salt and sand from a mixture of salt and sand. So let us say we are given with a mixture containing salt and sand. So in order to separate out the salt and the sand present in this mixture, first we have to dissolve this mixture in water. So when we see these two components, that is salt and the sand, salt it is soluble in water while the sand is insoluble. So when we dissolve the mixture of this sand and salt in water, the salt as it is soluble in water, it will dissolve in the water, while the insoluble sand will be settling at the bottom. So this insoluble sand can be separated out from this mixture by the help of filtration process, in which we are going to use a funnel and a filter paper will be placed. Here we are going to place an empty beaker, and if we pour this mixture in this funnel, at the time the solution of the salt and the water will pass through the filter paper and it will be collected in this container, while the other sand which is insoluble will be trapped by the filter paper here. So in this way, we separated out the insoluble sand from this mixture, leaving behind a solution of salt and water only. So now, in order to separate out the salt and the water present in this solution, we are going to perform the process of evaporation, in which the mixture of this salt and water will be boiled by applying heat energy. When we apply heat energy, the water which can vaporize will get vaporized and gets converted into the gaseous form, while the salt which cannot be vaporized will be settling at the bottom at the end of this process. So in this way, we can separate out the salt and the sand by using 2 or 3 different types of separation technique. So in this case also, if we think of obtaining or if we think of getting the water in its original form, then we have to collect the steam that is produced during the boiling process of this solution. So when this steam, if it is collected and if it is allowed to cool down, then it will get condensed and it will get converted into the liquid form of the water. So in this way, the three components, that is the salt, sand and the water, can be separated out in their original form by using different separation technique. So it is not that when we try to separate the components of a mixture, we are going to use only one separation technique. So depending upon the components that is present in the mixture, we can use different type of separation technique together in order to separate out all the components of that mixture. So now let us come to the next topic of this book, the last topic. The last topic of this chapter is, can water dissolve any amount of a substance? Before going directly into this topic, let us first discuss what is a solution and what are the different components that is present in a solution. The mixture which is formed by mixing a solid substance or any other liquid substance in water, we call it as solution. So when we say a solution, the solution is formed by two different substances. One is known as the solute and another one is known as the solvent. Solvent is the component of the solution which is taken in a large amount and in that the other substances are mixed. So in most of the solution, the solvent is the water. While the solute is the other component of the solution which is taken in a small amount. It can be a solid substance or it can be a liquid substance. So this solute is taken in a small amount and it is mixed in this solvent. So when the solute and the solvent are mixed together, then the substance or the mixture that we obtain, we call it as the solution. So the amount of the solute that can be dissolved in the solvent to form a solution depends upon the amount of the solvent and the temperature of the solvent. With the increase in the temperature of the solvent, the rate of dissolving the solute in the solvent also used to increase. But with the decrease in the temperature, a small amount of the solute can be dissolved in the solvent. So let us see the answer of this topic. Can water dissolve any amount of a substance? The answer is no. Depending upon the temperature and depending upon the amount of water that we had taken, a fixed amount of solute can be dissolved in that water. So it is not that if we take one glass of water, we can dissolve as much solute as we want. It's not that. A particular amount of solute can only be dissolved in a particular amount of a solvent at a particular amount of temperature. Now let us take a glass of water as an example. If we put a teaspoon of salt, this teaspoon of salt, when we mix in the water and when we stir it properly, the salt will be dissolved easily. But if we go on continuously adding the salt in this solution or in this water, we will obtain a stage in which no more salt can be dissolved in this solution. Such stage we call it as the saturated stage. And the solution is known as the saturated solution. During that time, doesn't matter whether we stir the solution well or not, there will be some amount of salt or some amount of solid that will left at the bottom of this container undissolved. This undissolved solute that is present in this saturated solution can be made to dissolve by applying extra amount of heat energy. Suppose in this solution which is in the saturated stage, if we apply heat energy, then the temperature of this solution will increase. During that time, slowly and slowly, this undissolved solid will get dissolved in this solution. So, with the increase in the temperature, the rate of dissolving the solid in a water can be increased. But after this salt or the solute get dissolved after the application of heat energy, if we apply extra amount of salt again and if we try to stir it, then it will get dissolved easily for some duration of time. Then again, another stage will reach in which no more solute can be again dissolved. Such a stage we call it as a highly saturated stage. and the solution will be known as the highly saturated solution. So after reaching this highly saturated stage, if we turn off the flame or if we stop applying extra heat energy and allows the solution to cool down, then slowly and slowly the amount of undissolved solute that gets settled at the bottom will increase. It is because with the lowering of the temperature, the extra amount of the solid that got dissolved after the application of heat energy will be again released out by the solution, and it will be settling at the bottom in the undissolved form. So this is because with the lowering of the temperature, the rate of dissolving a solid in a liquid also used to reduce. So these are the things that we studied in today's class. In the next video class, we will take up a new chapter. So for today, let us wind up here, dear students. Thank you.